My name is Kelly Morrison. I'm here to present today on the topic AI-Proof Your Career with Software Architecture. And there's a lot of tracks going on right now, and I know when I'm at a conference, I'm always overwhelmed. I don't know which one to pick because you only get to choose one of a number of tracks. So what I've gotten here is today's agenda. This is what we're going to be talking about today. If this looks like your cup of tea, join us. We'll be glad to have you. If there's something else going on you think you'd rather attend, go ahead and go. But if you sneak back in at the end, I'll have a link to the slides from today's presentation, so you get to see it. Plus, if you come back in at the end, you get to see a cute picture of my puppy dog, so win. But what we're going to talk about today, I'm just going to give you a brief introduction to who I am and why I'm talking about this today. I'm going to tell you how I learned how to avoid this bright light so my big, giant, misshapen head doesn't cast a shadow on the slides. We're going to spend about a minute each on GPT, Copilot, and Code Whisperer. These are 3 AI tools that people are using today to generate code. Then we're going to look at a couple of low and high-level prompts, what they can do properly, what they can't do. And then we're going to look at issues with AI code generation. A lot of people are scared of AI. They think it's going to take their job away. I'm going to give you some reassurance that that's not the case. Your job's not going away. It'll be a little different, but it probably won't be going away. So I'll give you some reassurance. But we'll go through some of the issues. We'll look at some of the things that AI won't be able to do for a while, some things they'll probably never be able to do. Then I'm going to give you some specific guidance. If you're a new programmer or just out of school or haven't been in it long, I'm going to give you some guidance for a junior developer about what you can do in your career to try to transition into this new exciting age. If you're a senior developer, I'm going to give you some guidance about how to use architecture to AI-proof your career. As you probably guessed from the title of the presentation today, most of the issues of AI code generation tend to be in the architecture area. So I'm going to give you some hints about how to take advantage of that, how to go about learning architecture, and then I'm going to give you a brief look at a tool called Arch Unit. This is a tool that can help you enforce architectural decisions in computer-generated code. So if you've got a bunch of junior programmers that are just going crazy generating code and checking it in, this helps you keep an eye on it, make sure they stick to the overall plan. And then we'll have a little time at the end for questions, and I'll give you links to my LinkedIn page, the GitHub repo where I'll post the slides tomorrow. And like I said, a cute picture of my puppy dog. She's adorable, you'll love it. Okay, as far as who I am, my name is Kelly Morrison. I've got a bachelor's degree in mathematics from the University of Georgia, so go dogs. I love seeing the Georgia things here and there. I also have a doctorate in computer engineering from Auburn University. My special is in compilers and grammar theory. I'm a compiler nerd. I love compilers. I'll talk about those all day long, but not today. This is a different talk. For the past 30 years, I've been in the software industry. I've been at a lot of startups like Pathfire, Performance Matters, Colorbus. We've done a lot of things you've seen. For example, Performance Matters. We used to grade tests for just about half the schools in New Jersey, half the schools in Florida, quite a few in Georgia, and then all around the country. I did some contract work for the Marshall Space Flight Center. That was back when we were building the space station on our own. Back then it was called Space Station Freedom, and I did some work for that. Eventually we brought other countries in, became the ISS, and now they're planning on dumping it in the ocean, which I'm sad to see happen, but hey. I've also worked at some big names like CNN, Home Depot, Turner. Right now, I've just got off a gig with Bayer. Bayer is the way we pronounce it here in the US. And right now, I'm working for Edward Jones Investment Company. So that's a little bit about who I am. And I was trying to think of a good picture to represent how I feel about AI and software engineering. And this is the one I came up with. Excuse my poor Photoshop skills, but I kind of feel like Rocky Balboa. Rocky was one of the best in his field. He was the boxer. But even he wouldn't be able to stand up against a robot, rock'em sock'em robot. That robot never gets tired, so you can't use the Clubber Lang strategy on him. He's never going to wear out. He's just relentless. He can learn from other robots that are taking place elsewhere. So Rocky's in for a real fight here. This is tougher than Drago or Clubber Lang or any of the rest. And I kind of feel like that. I feel like I'm a pretty good developer. I don't think I'm average, and I don't think I'm smarter than the average bear. I just think I'm good because I've been doing it for so long. I've been programming for 40 years now. So even after a while, you do something for 40 years, you get fairly good at it. So I like to think I'm a fairly good developer. The problem is, AI came in and basically changed our industry overnight. The thing is, though, I've been thinking about this for a long time, actually since 1986. Does anybody remember a movie called Watchmen that came out a few years ago? Okay, if you do. How many people have actually read the book, the graphic novel? Okay. Back when I read it, way back in 1986, when dinosaurs roamed the earth, there was this one passage in it that really, caught my imagination. What happened? We had a character who was retiring, because this other character, Dr. Manhattan, who basically represents the atomic age in the book, he came in and changed everything overnight. But he was thinking, I work on cars for a living. I've got an auto garage. I've been working on cars for years, and even you can't change that. The cars are going to be around to stay. And the next panel, the guy's like, well, the new electric cars coming out next year will be a lot simpler. Almost no moving parts, really easy. They're practically disposable. And the guy, his world was just rocked overnight, almost matter-of-factly. And I have thought about that for the past 30 years, what it would be like for something to happen and just completely upend your world. And now, ironically, we're in that situation. We're in there with AI. So before we go into why AI is not as scary as we think, let's take a quick survey. I've got 2 questions for you. First one, who's afraid they're going to lose their job to AI? All right, we're pretty brave in here. Second question, has anybody already lost a job because of AI or know someone who has? You do, okay. Was it you or someone else? A graphic designer? Yeah, Mid-Journey is kind of painful for them. Yeah. Okay, well, if you're worried about it, and not many of you seem to be, I'm here to reassure you. How many of you were here for the opening keynote that Mark Thompson gave? Quite a few of you. Actually, is Mark here today? Oh, well, I came to his talk. Yes. Well, to be fair, I had to walk out for 15 minutes during probably the best part, but I looked at the slides. I had to walk out and talk to a client because as fascinating as this talk was, the clients pay the bills, so I had to go out for a minute. But anyway, I'm here to reassure you, AI is not as scary as it thinks, and like I said, you're probably not going to lose your job to it. It'll be a little different, but you'll still have jobs. And I'm here today to show you some of the shortfalls of AI, how you can take advantage of that, and how you can position your career so that you can actually take advantage of it and ride the AI wave. So let's get started. First, let's take a quick look at what tools are out there. The first one, of course, is GPT, Generative Pre-Training Transformer. This is where basically the modern AI age started. This is what we call a large language model. And what that means is that it basically sucked up a huge amount of text and it parsed it out. It looked at what words are in close proximity to each other, positional order, and it managed to encode it. And then, given a prompt, it can actually go back out and pull out information and construct an answer to your question that looks like it thinks you want the answer to look. Sometimes it's right, sometimes it'll just make up stuff. But we'll get into that in a little bit. Anyway, this became popular about 6 years ago in 2017, and then GPT came out by a company called OpenAI in 2018. And they've gone through several iterations. There's GPT 1, 2, 3, we're up to 4 now. It's been growing by leaps and bounds, and it really became popular with GPT 3, 3.5, somewhere in that area. That's when everybody suddenly discovered ChatGPT, and it's like, wow, it can do my homework for me, awesome. Or in South Park, hey, it can talk to my girlfriend for me, awesome. So, by the way, I wouldn't recommend that as a strategy. I got divorced last year, so. Yeah. How can we measure, how much better it's getting from iteration to iteration? Well, there's something called a parameter. Now, a parameter is basically a variable in it that it uses to infer new content. For example, if you ask it something, it uses parameters to look up information, compose an answer. GPT-2 had 2 billion parameters, which seems like a staggering number. But just a couple of years later, GPT-3 had 175 billion parameters. It's like an 80-fold increase. Now GPT-4 has 1 trillion parameters. These numbers are getting huge. And what happens is you start sucking up more and more of the internet. As the internet grows faster and faster, you've got more and more knowledge that you can process and encode and use to look up answers. So GPT, this is basically the mother of all the modern AI. This is the one everybody's familiar with. And of course, there's a chat front end for it, ChatGPT, which I'm sure everybody here has used. Then there's GitHub Copilot. Microsoft, which owns GitHub now, and OpenAI got together, and they put together a specialized version of GPT that looks at code. And of course, like since Microsoft owns GitHub, and GitHub has pretty much everybody's code in it, it went out there and slurped up all that code, processed it, encoded it, and started working with it. Well, they used that version of GPT-3. They also wrote some algorithms to go with it to make it a little easier to use for code generation. And then they created what we call Copilot. And you can install this in your editor. Not only does it use the knowledge from all those billions of lines of code that it looked at, it can also scan through your code base, use that as part of its training, and then develop other code that fits in with what you've already written. So it's pretty powerful. Meanwhile, Microsoft's doing this, so of course Amazon gets jealous, and they come up with Code Whisperer, which is a cool name. This only came out last year, and again, it's trained on billions of lines of code, all the stuff on AWS. It's a little more limited than Copilot. Copilot works with just about any language. Code Whisperer, the last time I looked, really only supports about 15 languages for code generation. And as you would probably expect, since it was trained on AWS stuff, it's by Amazon, it's really specialized for AWS cloud development. So if you're going to work on AWS cloud development, Code Whisperer might be the way to go. If you're looking at something like GCP or like any other language like C, C#, Java, Scala, Rust, Clojure, you probably want to go with Copilot. But anyway, Code Whisperer has got some interesting things. Like Copilot, it can look at your code and the comments in the code and use that to help generate code. So those are three of the leading code generation tools we have out there right now. Now the question is, how good is it really? I'm sure most of us have tried a simple example and thought, oh wow, that does a lot of my job for me. If it could just go to meetings, they wouldn't need me anymore. But if you really start to examine it, it starts to fall apart a little bit. And that's what we're going to look at today. First, let's look at a really simple example. This is a prompt I wrote. And by the way, on the prompts I use in this, I actually went back and regenerated every one of them last night. So you're looking at last night's version of ChatGPT. These aren't responses from 6 months ago. But what I asked it to do was to just write a Java 17. And remember, I asked it to use Java 17. I wanted to write a Spring Boot REST API, and I wanted to store and retrieve baseball statistics in the MongoDB database. Pretty standard. I also asked it to use JUnit 5 test cases, and I wanted to check for the 5 most common REST errors, so it could handle those. So, hit the button, and here's what it came out with. First, my glance is wow, it wrote the entire program for me. I don't have anything to do. But then you start looking at it, and things start to look a little fuzzy. For example, the MongoDB configuration. This is where it configures how it connects to MongoDB. It generated everything properly. It uses the Mongo client configuration, which is a class I didn't know about. I've usually used other databases. It basically set up a configuration file for me. But if you look at it, it actually hard-coded the local address in it. So this will work if you're running locally, but if you want to deploy it to development or QA or production, that's not going to work. So you're going to have to go in and twist that code around a little bit so it can get different versions. Since you're using Spring, you might put the config information in different profiles, have a dev profile, a production profile, but still you have to get the information from somewhere. So you can't just use that code as is. You have to go back and tweak it a little bit. The next one, it created a simple database entry for me for a baseball stat. I asked it to write a microservice to store baseball stats in a database. So it came up with something, surprise, surprise, called baseball stat and put in a couple of fields for it. Now, remember I asked it to use Java 17, which is fairly recent. The interesting thing about this is that you'll notice it uses Lombok. Lombok is a very popular tool. It's basically a preprocessor for Java. It lets you add annotations like data or document or ID. And during the preprocessing phase, it goes through, picks those out, and puts in Java code, and then compiles to Java code. Now, if I was using Java 17, I probably wouldn't be using Lombok data for this. I would probably use the Java record, which has been introduced and has been out there for several iterations now. I asked it for Java 17, which is actually fairly old. We're up to Java 21 now. So this is a fairly old request I asked, and it still went back and gave me even older code. So it's not cutting edge here. We went back and used something that a lot of people are actually getting away from. I like Lombok. I used it for years, but sadly, Java is actually absorbing a lot of it, and you don't really need it that much anymore. Here's some more code. I created a REST controller for me. Then it showed me how to implement the common REST endpoints. I did a few things I like. For example, instead of request mapping with a parameter to tell what type, it actually used the shortcuts like post mapping, get mapping, and such. But if you look at it, all it did was stub out a method. Each one of these returns something, but it doesn't have any return code. If you just stuff that out there and try to compile, it would light up with syntax errors. You have to go through and fill it out. This is probably the easy part. Implementing a logic to do all this, that's usually the difficult part. And it just punted right over that. It's you do that. I've done my part. So you'd have to query a little harder to get it to give you information for that. And then finally, here's one of the unit tests. And honestly, when I was working with Spring Boot, the tests were usually an order of magnitude harder to write than the actual code itself, because it is so picky trying to get Spring Boot up and testable. There's just so many issues with it. But anyway, it basically generated one little test case. It basically says if I put something in the database successfully, then it's going to return an isCreated status, which is a 201. So that looks good, but there's still some issues with it. For example, the baseball stat here, does anybody remember what the 20 and the 50 are? You, sir, have a good memory. I actually pasted that in. I've looked it over several times, and even I can't remember it. What I would do if I had a code base like that, since we're already using Lombok, I would probably throw a builder on it so that it would say new baseball stat with home runs 20, with years at bat 50 or something like that. So it's a little more clear for somebody looking over the test. Another thing that I would probably have done differently, you'll notice that it actually auto-wired in a couple of fields. It's been a year or two since I worked with Spring Boot, but I seem to recall that it's better if you write a constructor and pass them in instead of auto-wiring a field. It's kind of like a subtle distinction, but there's advantages to that. So this probably isn't the way I would have written this. But still, it generated a lot of code for us. Most of it would work if you filled out the blanks, like the return code and such. So, overall, it's not too bad. Now, let's try something more complicated. I actually typed this prompt in to see what it would do. This is basically write the software for my company. Show me how to write an entire enterprise software system. I want to sell 10,000 craft supplies. I want to have OpenID security. I want unit and integration tests. I want a deployment pipeline. I want management APIs so I can look it over. I want backup and rollover processes in case, Philadelphia gets hit by a meteor and we have to roll over to Tempe, Arizona. I want an SLA of less than 100 milliseconds while I've got 100,000 concurrent users. I want localization for North America, South America, and Europe. So basically I want French for Canada, English for the US, and I want Spanish for South America. I want to be able to handle personally identifiable information so it's not exposed. And I want to conform to Sarbanes-Oxley standards in case we ever get audited. And I want documentation so I can understand what did you do. Now, I type this in, I hit return. And what do you think happened? This seemed like a perfect place to put in a Rocky Horror slide, since Halloween's coming up. So, if you've got it, let's anticipate it. And here's the answer. It punted. It didn't do a single thing I asked. Like my Auburn Tigers, which have no offense whatsoever this year, it just punted the ball away. It said, nope, you do it. The only thing it gave me back was some vague, high-level, explain it to me like I'm 5, basically hey, here's how you write enterprise software. Gather statistics, get requirements together, and then you write the code. How hard is that? This is basically useless. So if you think that Elon Musk is going to be able to take ChatGPT-5 and type in a prompt like that and get Twitter's entire ecosystem out, that's not happening. It's not happening next year. It's not happening in 10 years. In fact, it probably won't happen before I'm retired and dead, which is coming up pretty close, actually. It's scary, but anyway, the upshot here is that it handled something fairly low level easily. It generated a REST service for me. But when I asked it for something higher level, it gave up. Said, nope, you do that. So what that means is that we still need architects. Junior programmers, they're probably looking at their watches like, yeah, maybe I should go into, I don't know, like OnlyFans or something, dance around in bunny costumes. People might pay for that. But for architects, they're going to be needed for quite some time. So here's what we have. AI can do the groundwork for us. You still need humans to do the large level orchestration. And those are software architects. And what I'm going to do today is basically tell you a little bit about some of the things that AI can't do well and how architects can fix that. Here's some issues with AI-generated code. There are quite a few of them. The first one is what I call garbage in, garbage out. This is an old term, but it's still useful, especially with GPT-3. Where did GPT-3 and Copilot and Code Whisperer get all their knowledge about software? They got it from GitHub. And where did GitHub get it? All these developers all around the country, all around the world, putting their code out there. Now, not all of it is good. Not all of it's even correct. A lot of it won't even compile. It's just like something somebody put out there for a class assignment and never finished. And some of it's actually obsolete. When's the last time you saw somebody running a struts program? That's probably not useful anymore. And people are still putting new code in it. And every time somebody puts new code in there, ChatGPT sees it and trains on it. So that means you keep putting in bad code, it's going to learn bad code, and it's going to start recommending bad code. So that's an issue. There's a lot of good programmers out there. GitHub includes a lot of code from people like at MIT and Stanford and Caltech and Auburn. But it also has high schools out in the middle of nowhere where they don't even know what Java is, and they're just fumbling around. But it's still got put out there, and it's still got pulled in. Something else, I used to work with a programmer who used to say this George Carlin quote a lot. George Carlin once said, think of how stupid the average person is, and then realize half of them are even stupider than that. Well, my coworker said the same thing, but he always substituted programmers for person. And I've seen some horrific things out there. In fact, just a few years ago, I was on a job where we had a program that pulled information out of a database and displayed it. And it worked great. We were working on it for months. We were getting close to production. So I wrote a script and filled the database up with what I thought a production load would look like. When we fired at the program, it ground to a halt. We got the spinning beach ball of death for 30 seconds, and then it timed out. And I was thinking, what happened here? So I went and dug into the code, and what had happened was one of the programmers that actually was pulling the information out of the database and formatting it, they didn't know how SQL worked. Now, they didn't know it at all, and they didn't want to ask anyone. So what they did, anytime we had to query the database, they basically said select star and pulled everything back. Then they sorted through it in Java because they knew how to do that. And somehow this got through a PR review. I think people were asleep at the wheel and just yeah, click, it's good. But we didn't find it until we were about to go to production. I saw that, and I just about had a flat-out, old-fashioned Southern hissy fit. And if the programmer wasn't all the way up in Minnesota, I would have probably gone up and yelled in his ear for a few minutes. But anyway, we have people like that writing code, putting it out in GitHub. These tools are training on it, and then they're using it to recommend code for us. So that's an issue. Another problem, this is a huge one, hallucinations. Does everybody know what a hallucination in AI is? Okay, well, here's what a hallucination is. This is a really high-level answer. It's probably not perfect, but it's enough to get the idea across. GPT isn't thinking. It doesn't really understand what it's looking at. It doesn't know the difference between the recipe for my mom's mac and cheese casserole than it does a REST API. All it does is it looks at things that are similar to what you asked for. It looks at things that were close to it, and it composes something that it thinks is close to what you want for an answer. It's a mimic. It's a mime. It's a parrot. That's what it is. Now, the good thing about it, most of the things we ask it, people have already asked before. There are zillions of REST APIs out there that pull from a database. There are zillions of APIs out there that put up a login page and process it. So if it's something it's seen before, it's going to give you a pretty good answer on it. Because it's seen it before. It can just customize it a little bit for what you want and bring it back to you. But if it can't find an answer, if it can't find enough things similar to what you want, or it can't find anything similar to what you want, it'll make up something that looks like what it thinks you want, even if it's just completely made up. We call this a hallucination. And I've got an example of it right here. I was working on Kubernetes a while back, and it had been a while since I'd used it. So I asked it, how can I create a pod and give it a name? And it came back and said, yeah, Kubernetes create -f YAML file, then -- name equal in the name. So I tried that, didn't work. Went through all the documentation, couldn't find that parameter in any version of it. So I said, hey, it doesn't recognize that option. And it came back and said, yeah, you're right, it doesn't. Sorry about that, no harm, bro. But it'll just make up things. And that is a huge problem. I've had the same thing with regular expressions. One of the things that ChatGPT is actually good at is explaining code, especially like regular expressions. If you have a complicated regular expression, you can put it in there, say, hey, explain this to me like I'm 5, or explain this to me like I went to the University of Alabama. Yeah, I'm from Auburn. And it'll give you a really good text description of it. Problem is, if you ask it to write a Unix command to grep out stuff for a regular expression, it'll sometimes make up parameters. I had to really fuss with it one night to do that. Another problem is monkey see, monkey do. Like we said, it's trained on what it's seen before. So what happens if a brand new language or framework or technology comes along? It doesn't have any training data. So how's it going to recommend things to you? Well, at first, it's got extremely limited training data, but all the people that are new to it are going to be asking ChatGPT, hey, how do I write a Mogo function to do this? And it doesn't know how, so it'll probably just use what it learned from other languages and then maybe kind of twiddle it to look like Mojo syntax. So right when we need good training data is the time we probably get the worst. So that means when a new technology comes along, the first data in there is probably going to be bad. And it's going to train on that. People are going to use that bad data, put it back in. It's going to train on that, and we just have this bad loop. So it's really important when a new technology comes along that we get some good data out there. And plus, sometimes it takes a while for technology to catch on. For example, the Rust programming language, created back in 2006. How many example programs do you think were available just in 2007 or even 2008? Probably not a lot. And just this year, there's a brand new programming language called Mojo, created in May 2023. I actually signed up for the preview on that and then haven't had time to work on it. But it's a brand new language. There aren't that many programs out there for it. So if you ask ChatGPT to, hey, help me write a Mojo program, it doesn't really have anything to look at. So it's probably not going to be very helpful. In fact, it's probably going to be more likely to hallucinate an answer that it thinks looks like what you want. So that's an issue we have to deal with. Then there's security concerns. This is a big one for me as a consultant. Every time ChatGPT interacts with you, it learns from you. You don't just type in stuff for free and it gives you answers out of the goodness of its heart. It takes that information and it uses that to train its LLM for the next time. Problem is, if you ever accidentally put private information in, it's almost impossible to get it out. You can't just go to an LLM like it's a database and search for Kelly Morrison and delete that record to get me out of there. No, when you add stuff to an LLM, it gets thrown in there. It's weighted here and there. It's almost impossible to even find where it is in the LLM. And trying to delete information from an LLM is actually a good research problem right now. In fact, if any of you are considering a master's or doctorate in computer software or engineering or AI, that's actually a good problem to work on right now. Because there are people who would gladly pay for that right now. So the problem is, if private information leaks into the LLM and you can't get it back out, that means your private secrets are out there publicly. It's like having somebody take your Google history and post it on a billboard outside the World Congress Center. You probably don't want that. So you have to be careful about passwords, intellectual property, trade secrets. So for these reasons, a lot of companies actually forbid you to use it. You can still use them, but you have to be careful about it. For example, you have to make it anonymous, and it's probably better to air gap it so you can't even trace an IP back. For example, if I'm at work and somebody says, hey, I need you to write the service for the super secret, AA project, I can't type that in. So I'll think of something similar, hey, show me how to do a web API for, a baseball service. I look at the answer and I kind of mentally translate that back into what the client wants. So that's one way to do it. So that way you can kind of get around, you don't actually put confidential information in, but you still get some use out of it. But it's still awkward, and there's really no good answer for that unless ChatGPT says, hey, we're going to give you an option not to learn anything from what you type in. Of course, as soon as you do that, you're going to start paying for it. I don't want that. Debugging. It's really easy to generate code with an AI tool. Even somebody that doesn't know much about it, you don't even have to know, for example, Go. You can just say, hey, write me a Go program with a gRPC API, and it'll spit out the code for you. But the problem is it correct? The code sample I showed earlier has some compile errors. Plus, it wasn't really the best code. And then the serious one, if an error occurs in AI-generated code, and no one at the company has ever really looked at it or thought it through, who's going to debug that? You could ask ChatGPT to debug it, but that means typing the code back in and throwing it in there, and then all your information gets leaked out and incorporated in the next version of the LLM. So that's probably not a good one. Sometimes GPT and Copilot can debug code internally, but you got to be careful about posting it in a prompt because you don't want to leak any confidential information. So even though AI wrote the code, it's probably going to be humans that have to go through and fix it. That's kind of actually the hard part. It's easy to write code. It's a lot harder to fix it many times. Then there's some tasks that are actually easier for humans than API. For example, frameworks. For example, if we had Lombok and we decided we wanted to ditch that, but we used the logging in it, we might want to just switch all the log statements to SLF for J. You can't really use ChatGPT to do it because you'd have to type your entire code base in and have it spit out the corrected version. Same thing with Copilot. Copilot could do it, but then you probably leak information again. Sometimes it's just a major shift. Does anybody remember when we went from Angular to Angular 2? Yeah, if you're not familiar with that, Angular, there was the first version of it. Then they came out with a second version. They decided, okay, we've learned a lot, so we're going to fix it this time. But they didn't make it backward compatible. So you couldn't just change a version number. You had to go back and rewrite a lot of your code to work with Angular 2. And this is another kind of thing where it's probably easier for a person to do than for a computer. Because if the LLM doesn't have a lot of Angular 2 code to look at, then it's not probably going to be able to map it very easily. Also, if you want to change something like Angular to React, that's not exactly an easy lift. To a layperson, Angular and React are both ways of doing a UI, but React is pretty much focused on the user interface. Angular is a whole infrastructure. It's user interface plus a whole lot of other stuff. So it's not really a one-to-one mapping. It's kind of hard to have LLM do that. Another example, Java used dates for the longest time, and then in JDK 8, it switched to the datetime API. And I saw so much bad Java date code that a lot of it, even if LLM tried to transform it, it would still have been bad. In fact, it may have been worse. So sometimes you really just need human eyes to look at it. And there are some things that are just inherently easier, like CSS. An AI can't really look at a web browser and say, hey, that's off, or that sentence is off screen. It's really difficult to do that. So again, you need a human to look at that and make sure everything looks proper. Then there's major architectural changes. For example, let's say if somebody comes back from a conference, hey, I learned domain-driven design. I think we should use it for everything. So let's rewrite this program to use DDD. Is anybody in here familiar with domain-driven design? Few, okay. Basically, the idea is that you want to write software that reflects the way a person sees it, not the way a human sees it. So there's a lot of emphasis on talking to people, figuring out their language, and then expressing ideas the way a human would instead of the way a computer would. And since we're trying to express things the way a human would instead of the way a computer would, it's probably a bad idea to ask the computer to do it for us. If you want something that has a human perspective, you really want a human to do it. And then finally, computers don't understand when requirements change. For example, the CEO changes at your company. The new CEO got fired from Amazon or Google at some point in their past and suddenly decides, hey, we're not using AWS anymore, or we're not using Google anymore. ChatGPT doesn't do that. If you ask it to do something, it may use one of those tools, and you have to tell it, no, we can't use that one. So it doesn't understand a lot of the decisions going wrong. Then there's industry reluctance. We don't really see it in the software field yet, but we may soon. But if you look at other fields like this, some of them are pushing back hard against AI. For example, the legal field. One of the cases, there was actually a case a while back where someone actually came up with an AI agent for being a lawyer. And they wanted to take it into a courtroom. And oh man, they had so much pushback about that. First they didn't even want computers at all in the courtroom. They especially didn't want a computer lawyer. So there was a lot of pushback about that. There was another case where a lawyer got lazy and decided to use ChatGPT to do research, for legal precedents. Problem is, AI couldn't find any, so it hallucinated some. It just made them up. It could have been in the case of Mickey versus Goofy, but it just made them up, and the lawyer didn't check it. He just took the results, dumped them in a brief and sent it to the judge. The judge was a little more thorough, and he's like, I've never heard of these before, and got to looking them up. It's like, these are made up. That lawyer got in a lot of trouble. So we're seeing pushback. You can't make up legal precedents. That's a bad no-no. And lawyers, if you're making $300, $400, $500 an hour, you don't want a program to come in and take your job away. So they want tools to help them with their jobs. They do not want tools to replace them. Same thing with Hollywood. Hollywood's on strike right now. They're basically scared stiff of AI. They're afraid AI is going to write scripts for them. And why not? There's a zillion old TV shows, plot, scripts, characters, even character arcs out there. You just ask it for something similar to what you want, it'll happily spit out an episode. There was one site I looked at, it actually continuously wrote Seinfeld. Every day you just log in, it's more and more Seinfeld conversation. So Hollywood's a little scared about that. So they're pushing hard against AI code. I keep thinking software development's going to be next. If it gets better and better, I think we're going to start seeing some pushback about when AI can be used. One wild card is about whether or not AI-generated software can be copyrighted. And we got a partial answer earlier this year. Back in March 2023, the United States Copyright Office said that if you use AI to produce a work, it may or may not be copyrightable. If you just take output directly from an AI, it's not copyrightable, because you didn't create it. There has to be enough human intervention with it for it to be arguably human invention and therefore copyrightable. So I keep thinking we're going to have further development on that, but for right now it's a fuzzy area. So if you're writing AI code and just dumping it out, it might be a trade secret for your company, or it might not be. Then there's critical software. I would argue there's some software that's just too important to trust the AI tools, especially when they hallucinate things. For example, avionics software. How many of you would get on an airplane that was used, where the avionics software on it was written by ChatGPT? Anybody? Yeah, me either. What about full self-driving car software? Would you trust software that only AI wrote for that? You're going to put your grandma in it and send her through Atlanta traffic to the grocery store? Not me. And then there's things where where people's lives literally depend on it, embedded software for medical devices, like pacemakers. I used to joke about I never wanted to get old and have a Windows pacemaker in my heart because I'd be dead in a year. We may have the same problem with AI-generated code. And then there's sometimes it's just too expensive to have a mistake. For example, spacecraft and satellites. If you're spending $2 billion to go to the moon, you don't want some AI-generated code that forgot to handle this possibility or that to blow up the ship. Then there's contextual awareness. AI tools don't know what other software exists at a company. All they know is what you're typing into it. So you go into a large company, especially that's been around for decades, there's a wealth of software and software knowledge out there. AI doesn't know anything about that. It doesn't know about your company's standards or practices. It doesn't know if you can tweak or reuse existing software instead of creating a new one. They don't even know why certain decisions were made. For example, everything might be GCP instead of AWS. It doesn't know why. And it doesn't understand security concerns. For example, if you ask it, hey, pull out a social security number from the database, it's all right, here's the code for it. You try to check that in a PR review, I'm no, you can't expose data like that. And I think this is the last one, lack of creativity. Again, large language models don't think. Like I said, they're mimics, they're parrots, they're mimes. They don't think. They just look at what you asked and try to construct something that looks like it thinks the answer should be. I don't think an LLM could have created the DVR time-shifting software. Reason why? I don't think it could have come up with the MPEG-4 encoding algorithm. There's some really high-end math in that, and there's some really bright people that came up with that. LL and LR grammars, general compiler theory. I don't think ChatGPT could have figured that out on its own. What about the layered internet protocol? Or, like I said before, how to self-drive a car? How can you tell if it's a deer running out in front of the road? How do you know it's a real tunnel and not a wily coyote like painted one on the side of a rock? There's a lot of stuff in there that people had to figure out. So if you think about it, there's always going to be room for software, pure original thinking. There's always going to be problems that machines just can't solve yet because they haven't seen anything similar. And this is one of the things that we can capitalize on. Okay, so now that I've nailed it to the wall and showed all the things it can't do, right? Let's think about what it can do, right? It can do low-level code generation, REST APIs, configuration, database access. That's a snap. There's hundreds, maybe thousands, maybe tens of thousands of examples in GitHub. It's pretty good at code optimization. If you've been in some sloppy code, it'll usually give you a better version of it. It's really good for greenfield development. If you just don't have any code at all and you want to start from scratch, it's perfect. It'll spit out a skeleton framework for you and it'll explain it in plain English. It's really good at documentation. You can use it to generate test cases, which is, to me, is one of the more boring parts of software development. So automate it. Say, hey, I want to test for this error. Give me a test case for it. And these are basically the kind of tasks that you usually hand off to a junior developer. So if you're a junior developer or a senior developer even, what are you going to do? Well, one thing you could do is focus on architecture. Like we saw earlier, it's going to be a while before computers can do everything for us. Elon Musk, again, isn't going to be able to say, hey, write a message system that can handle tens of millions of concurrent users and have 99.999% uptime. That's not going to happen for a long, long time, if ever. People are going to have to do a lot of the intermediate work there. If you're a junior programmer, just getting started or haven't been in the field long, here's some things I would recommend you do. First of all, don't just learn a language or a framework. I meet too many people who say, I'm a Java developer, or I'm a React developer. No, what you need to do is focus less on the language itself and what it's doing. You need to learn a little bit about a lot of languages. Learn which languages are best in which situations. Why do data scientists usually use Python? How come people write system software use Rust? How come people write run-of-the-mill applications use Node or Java or Spring Boot? There are reasons for it. So take a look at the languages critically, figure out what the advantages and disadvantages are. Next, learn the common idioms. Once a new language comes out, everybody's fumbling around at first, but after a while, people start coming to a consensus about the best way to do things in that language. We call these idioms. Learn those so that when you ask AI to generate software, you can check to see if it's doing something in the style that most programmers in that field use. You also want to look at other things that a software wouldn't consider. For example, if you ask what's the best language to write this in, it's not always the one that ChatGPT would recommend. There might be issues like pricing. Are the libraries I need available? You may use some third-party library that only works with one particular language or framework. You got to look at what kind of programmers are available. I worked for a company once, they used Clojure and Scala for everything. It was great. Those are languages you hardly ever get to use in the real world. The problem was there weren't a lot of Scala or Clojure programmers out there, so they had a really hard time hiring people. So they came in one day and said, hey, we're switching everything to Java. It was almost a revolt. About half the company just about up and walked out that day. They were angry. And one of the things I got called in to do was do a little fire control there. We basically showed that Java 8, with the application of a few libraries, could actually do a lot of the things you could do with Scala. It was a little clumsier, of course. It wasn't as pretty, but you could still do them. And that helped save a few people. Well, I learned the architectures that are best implemented in various languages. Some languages are better for certain architectures than others. You want to learn how to create great prompts for code generation. It's not enough to just say, hey, create a REST API for this. You want to ask it things like, write one that's bulletproof. You need to figure out a good way to say that. One that handles common errors. One that checks to see what happens if the database isn't available, or if it dies, or if I don't get back the right number of requests. You want to ask it to check for things like common OWASP errors, which is security. And finally, you want to learn to understand, follow, test, and debug AI-generated code. If you're going to have people in your organization generating code from AI, You want to be able to use it if it breaks. You don't want the dreaded 3 a.m. call where, hey, we need you to come in the office right now, and you go look at it, and you're like, what the heck is this? So it's like somebody spilled like alphabets on the screen. So you want to be able to understand AI-generated code. If you're a senior developer, what I would recommend is you become an architect if you haven't already. A good way is to start reading books about architecture, and I've got 3 good ones here. 2 are by Neil Ford, the ones on the sides. The one in the middle is Domain-Driven Design by Eric Evans. This one actually goes back a few decades, but it's still very relevant. Domain-Driven Design basically focuses on understanding the problem space, what the users want. Because you go out and talk to people, say, that are working on a farming application. They don't know anything about caches or Redis. They don't know anything about microservices. All they know is about crop yields and fertilizer and the best times of year to plant things. So what you need to do is learn their language. Learn to express things the way they do, and then copy that into the software. You want the software at a high level to be readable by the domain experts, and domain-driven design will teach you how to do that. The other 2, Building Evolutionary Architectures, that was actually required reading in a couple of companies I worked for. It's a great book. And then Neil just came out with a new one 2 or 3 years ago called Fundamentals of Software Architecture. This one goes through almost every one of the modern architecture that you will see out in the real world. He does a very good job of explaining it. And you can actually go online on YouTube and find several lectures he's given on this. So if you don't have time to read the entire book, you can spend an hour, hour and a half looking at one of his keynotes. So just look for Neil Ford, Fundamentals of Software Architecture. Okay, once you learn about architectures, you need to learn how to implement them. And there are quite a few. Does everybody know what a layered architecture is? Just show of hands. What about event-driven architectures? A few. Microkernels. Okay, microservices. Okay, I figured that would be the common one. Does anybody use space-based architecture, tuple spaces? Okay. There's client-server. There's a whole bunch of them. Broker, peer-to-peer, it just goes on and on. But again, read the Neil Ford book. He goes into the advantages and disadvantages to each and when you want to use them and when they're not recommended. So again, this is something that ChatGPT won't tell you. ChatGPT is great at like writing the little bits and pieces, but when it comes to like stitching them all together and overriding framework, this is where people come in. Another thing, like I call this divining requirements. Does anybody know what water divination is, or ever seen a divining rod? A few people. Okay, it's probably an old Southern thing. What you do is you take like a Y-shaped stick, or you take two sticks, and you just kind of walk along the ground with it. And at some point, like they'll either come together if it's like two sticks, or it'll kind of dip a little bit. And when that happens, you're standing over a water source. I know it sounds like witchcraft, but it actually works. I've tested that a few times. Like, we went to a building once that had a water main under it, and both my brother and I like tried it out, and we both pointed to the exact location where it was, even though we didn't know. It's kind of weird. I don't like things I can't explain. But just because I can't explain it doesn't mean it's magic. It's probably some kind of physics that we don't know about yet. So. But anyway, I think a requirements is the same way. You're just kind of like walking around with your laptop and you're listening to the people, and every once in a while like it'll dip. It's like, okay, that's something I need to know. So I call it like divining requirements. And AI-based tools can't really do that. Like Elon Musk, he's a brilliant person, but he doesn't know enough about the nuts and bolts of software to be able to specify an enterprise architecture system. So what he needs to do, he needs to talk to somebody that does know that, an architect. Architect is a bridge between people that know the domain and the AI tools. So you need to learn how to interview people. You need to learn how to coach them into telling you what you need to know. You need to learn how to tease out what's important and what's not. And the DDD book's actually pretty good about that. It actually has a few little software interviews in there, so I highly recommend reading that. And finally, once you have requirements, you need to be able to think about it and then figure out which one of those different architectures is the best one. Finally, you need to learn how to mentor junior developers. This is always an important part of a senior developer's day. What you want to do is you want to work with them, teach them how to craft high-quality prompts. At first, they're just going to want to know, hey, generate a REST API. You're the one who needs to tell them, you needs to be able to handle this kind of error, and needs to handle these security aspects. So work with them, teach them how to craft better prompts. Some of the things you might want to ask for when you're crafting your prompts, ask for security. You want to ask for test cases, documentation. If you're an architect, you probably see places where a particular design pattern might be useful. So you can actually ask ChatGPT, hey, like implement the builder pattern for this, or implement the visitor pattern here. You want to check OWASP, for security problems. You want to show juniors how to spot hallucinations, what to do if one occurs. A lot of times, if you're a little more specific or guide the AI a little bit better, it'll stop hallucinating, come back to reality, and give you something useful. You need to get them to understand if AI written code is sufficiently good quality to put in your code base. And you want to help them learn architecture. When you're fresh out of school, you probably know a lot about coding languages. You don't know much about architecture. That's the kind of thing you usually learn from experience. So when you're working with a junior programmer, don't just say implement X using framework Y. Give an explanation, like we're implementing X using Y instead of W or Z because of this. Teach them how to do architecture. Do the Karate Kid thing on them. And finally, you want to ensure that design specifications are met. AI can generate code all day long, happily. It might be good, it might be bad, it might not even be relevant what you ask for, but it'll just generate all day long. So what you could do is you could add pre-commit Git hooks to run some tests on it. You can lean on AI tools to generate unit tests. If it can write the code, it can write code to test it. And finally, if you're using Java or C#, I would look at something like ArcUnit. You can get to arcunit.org. Everybody here is probably familiar with JUnit, right? Is there anybody that's not? If you're not familiar with JUnit is a testing framework for Java programs that makes it really easy to write test cases. ArcUnit is very similar, but instead of writing test cases for code, you're writing test cases for architecture. It looks at how the code was implemented, how it's structured, how it's laid out, and it can flag it if it finds an issue. It's got a fluid interface. It's really easy to write in IDE. You can spit it out. A lot of times if you start writing it, it'll basically almost write the code for you. And you can write your own rules. And let me give you 2 examples, and then we'll quit and ask questions. Here's a couple of simple ArcUnit examples. Just like in JUnit where you just have &test, for ArcTest, it's just &ArcTest. And they come with a lot of built-in ones. For example, there's a role that checks to make sure that you don't throw generic exceptions in a class. You don't want to throw just a plain exception. You want to make sure, for example, you don't use the built-in Java logging. You probably want to use something like SLF for J. Down here, you can make sure you're not using the JOTA-time library anymore. Java 8 put in the datetime API. Let's use that instead. Field injection. Say, hey, we don't want to do that. And you can actually write more specific ones. For example, here we have one that says that if you use a logger in a class, it needs to be private static final. So what it does, if you look at this line, this is all actually one line of code. It's just a fluid interface, so it's formatted a little better. What it does is it gets all the fields in a class. And then it says that any fields that are a logger class, they should have a private access modifier, they should be static, and they should be final. And then it even lets you put a reason. The reason is because we agreed on it. This is the way we're going to write it. So you can write your own rules like this. It's very easy to get a hold of fields, classes, packages, that kind of thing. And then you can run all kind of tests on them. Even better, it has some built-in ones for different kinds of architecture. For example, you might be using a layered architecture. So here's a class that actually checks to make sure that you're following access properly in it. There's a annotation up here that says analyze classes. This is where you tell what packages to look at. For example, look at the layers and everything underneath it. Then we have an arc test here that says if we have a layered architecture, then if there's a controller layer in this package, and there's a services layer in this package, and a persistence layer in that package, then anything in the controller's package should not be accessed by any of the other layers. In other words, you can't call from persistence to controller. You can't call from service to controller. The services layer can only be accessed by the controller layer. So the controller can call services, services can't call controller. And then finally, persistence can only be accessed by the services layer. So the controller can't call the persistence layer directly. So if you have a layered architecture, you can write code like this that can run over your code base and look for problems with it. Somebody checks code in the wrong place, or somebody tries to take a shortcut and go straight from the controller to the database, it'll catch it and flag it. And you can make this part of your build, compile, CI/CD loop. Anyway, it's a really cool program. One day I'll probably do an entire lecture on that. But let's wrap this up because it's about time for lunch in about 3 minutes. So conclusion, AI can do a lot of junior developer tasks. So if you're a junior developer, you need to start thinking about that. You want to learn how to use AI properly, but you also want to kind of have your eyes on the horizon about becoming an architect. You need to learn how to incorporate AI tools because they're probably not going away. We have a few legal issues right now, about data leaking out, and once it's out there, it can't be deleted. But those will probably be solved one day, and then they'll be more common in the workplace. Knowledge of various architectures, trade-offs, costs, that's vital. If you're an architect, know that, you'll be able to work with AI tools very well. You need to mentor junior developers so that they learn architecture along the way and learn how to tell if AI code is good or bad. And finally, just by getting rid of the low-level grunt work, it can make things fun for us again. We can concentrate on the high-end design. We can do the fun parts of software again instead of writing yet another REST API. So that's basically where I'm at. Since it's almost Halloween, I threw up a David S. Pumpkin slide. I'm ready for any questions. And again, my name is Kelly Morrison. I work at Doherty Business Solutions here in Atlanta. I've got some old-fashioned business cards if you'd like one. If not, there's my work email address, my home email address. The barcode in the bottom left corner is my LinkedIn profile. The GitHub profile is up here on the right. The slides are not there yet. What I usually do is present. If there's any comments or feedback or if anything's not clear, I usually go back and tweak it and then post the slides later. So they're not up yet, but they will be by tomorrow morning. So if you go to that GitHub tomorrow, you should see the slides. And finally, there's my adorable Peppy, Daisy May. She's a French bulldog, and she's at home right now wondering where I'm at because I usually work from home. Anyway, that's it. We're out of here in time for lunch. Thank you for coming. I appreciate it, and I'll stick around if you have any questions. Thank you.